session, we are going to focus on inserting a node at the head of a linked list. It's again part of the linked list category under the data structures section. The problem is straightforward. We are given a pointer to the head of a linked list and required to insert a new node to the head. The next value is the new node should point to head and the data value should be replaced with the given value. Return a reference to the new node of the list after insertion. The head pointer given may be null initially, which indicates the list is empty. Functional description. Complete the function insert node at head in the editor below. So this is the editor. We don't have any function given here except for the main, which means we are required to implement the linked list from scratch and then implement insert node at head as well. The insert node at head function takes two parameters, which is a reference to the head node of type singly linked list node and then a data parameter. The input format here expects two standard input from console. It takes first line as integer n, which is the number of elements to be inserted to the head of the list, followed by the elements. Constraints go as here. The value of n, that is the number of elements to be inserted into the list, ranges somewhere between 1 and 1000, pretty huge. The value of the element is also between 1 and 1000. So it's basically an integer value. The sample input is like this 5, which is number of elements that needs to be inserted, followed by values of the elements, 5 elements. And the output will be 5 elements displayed from the modified list, one per line. Explanation on how this can be implemented is given here. We'll take a look into dry run and understand explanation a little better before implementing this Go code. Consider an empty linked list, list A. It is initially empty. It has two pointers, head and tail, pointing to nil. We are required to insert 5 elements as you see here. When the node is created, it holds a value val and a pointer to the next element in the linked list. Now, when we are required to implement addition of a node to the head of the list, we begin with creating a node. So let's say we want to insert 383. We would create a node and look for the status of head. If head is empty, we make the new node as head. We make the new node as tail as well because list is empty. So it's like this. Now we have head and tail pointing to new node 383. And this is going to be the new list. So I'm just going to say list A. This is going to be list A. Now, if we are required to add another new element or new node containing value 484, then we look for status of the head. Head now holds 383. This time, we keep the tail static at the same position, however, modify the head accordingly. So, the new node's next node will be the head, and now the head will be new node. So, we make head point here. The list is now 484, 383. Next, if we are required to insert third element with value 392, we perform a similar task of making new node's next pointer as current head and new node as new head. So we just make new node as head here. We perform same task with next node, say 975, we make the new node's next node as current head and we make new node as the new head. The list is now 975, 392, 484, and 383. Finally, we have the last element that needs to be inserted to the head of the linked list, and that's 321. We make 321's next node as head and 321 itself as the new head. So, so now the final list is going to be 321, 975, 392, 484, and 383. The list node definition is like this. It holds an integer value and a pointer to the next node in the linked list. With this background, let's go ahead and implement. We will now implement addition of a node to the head of the linked list. And for that, we need to build the linked list from scratch. As you see, only function main is available here. So from the previous session, we will pull out the code for creation of the linked list. And I'm just going back to the session where we had built linked list from scratch when making an attempt to insert a node to the tail of the linked list. Just going to take all of this code and again move forward and paste it here. So this time, instead of insert node at tail, it's going to be insert node at head. And now I'm going to redefine head here. So let us remove all of this except creation of node. So the creation of node remains same irrespective of whether it's going to be inserting at the tail or head. Now we'll check if head is nil. This dot head is nil. Then we make this dot head equal to new node and this dot tail also as new node. Otherwise, we know from our dry run, we make new nodes next as head and new node as new head. New node dot next equal to this dot head and this dot head equal to new node. With the typo here, let's fix it. All right. So we can go ahead and run this. It will take a while for processing. Perfect. We are done with the implementation. Both test case 0 and test case 1 have successfully passed. We can pass it through submit code also to make sure that multiple test cases are executed. Perfect. So all of these test cases are passed. So we don't need a tail pointer here when adding a node to the head of the linked list. So we could go ahead and remove it accordingly, make changes to the constructor also here as well. And run it again. Okay. The same piece of code executed. You can submit that as well. Perfect. Now I'm going to reduce the window size here and make one more tiny change here. Instead of making next node as nil, I'll make new nodes next as this dot head directly, and we just need to make this dot head as new node here. I'll run it again. That also works fine. There are about 6 new test cases and all of them have test. So all the ways by which we have attempted to implement addition of a node to the head of the linked list have successfully passed, and we are done with the implementation.